Okay, good morning. Now let us discuss the mechanism of Heck reaction. So we are taking the example Rx is reacting with plus R dash in presence of PD0 and a base we get R substituted alkene. What is the mechanism of this reaction? Okay, so we start with the PD0. PD0 means we can see that palladium in its zero oxidation state. That means palladium is joined with two triphenyl group, which can be represented as PD. That we know that PD L. What do you mean by L? That is triphenyl phosphine. In this bis triphenyl phosphine palladium 0. In this compound, this palladium is in a zero oxidation state. In the first step, you can see that the first step is known as oxidative addition. That means we are taking our halide, that unsaturated halide, that is RX. That means the reaction of palladium 0 with Rx. This step is known as oxidative addition. Oxidative addition. Okay, what do you mean by oxidative addition? As I told you, the palladium 0 can insert itself between the Rx bond. That means this is the insertion of palladium 0 between Rx bond or CX bond. That is what is known as oxidative addition. And after oxidative addition, what you will get? Look at here. Here it is R. Then palladium is inserted between R and X, and here is our L. Okay, L. Now you can see that when Rx and palladium 0 is joined together, its oxidation state, the 0 oxidation state is changed to +2 oxidation state. Here you can see that or 2+ oxidation state. Okay, that means. You can see that here the PD is having 4 bonds. That means the 0 oxidation state is changed to +2 oxidation state. So here you can see that palladium is again changed back to +2 oxidation state. This step is known as oxidative addition. Okay. Now in the next step you can see that this our alkene. Now alkene. This alkene is introducing into R dash. That means this step is what is known as coordination of alkene with PD2 plus. Coordination of alkene with PD2 plus. What do you mean by coordination of alkene with PD2 plus? This is what is known as coordination of alkene with PD2 plus. Coordination of alkene with the PD2 plus. That means look at here, this step only I am writing here. Okay, this continuing like this. You can see that here it is our R PD, here it is X, and here it is L, and here is L, and you can see that this is our R dash. So double bond R dash. This is our alkene. What do you mean by coordination of alkene with PD2 plus? That means there is an interaction between this alkene pi bond and PD2 plus. This is what is known as coordination of alkene with PD2 plus. And after that, what is happening? Look at it here. After this one, what do you mean by this coordination? What is actually, what do you mean by coordination? Look at it here. I am writing the same structure. R PD, then X, here it is L, here also L, of course it is in +2 oxidation state. What do you mean by coordination? See, here you can see that this is our this is our alkene. Here it is R dash. Okay, R dash. Okay, this is our R dash. R dash is here. What do you mean by coordination? Means look at it here. Here what is that? CH2 double bond CH R dash. The actual structure is CH2 double bond CH R dash, and you can see that the coordination of alkene with the PD2 plus means this R group, this R breaks from palladium and it will join with this carbon. Okay, so the bond breaks from palladium PD2 plus and it is joining with the CH2. That means okay, simultaneously what will happen? The pi bond breaks from this carbon and it will be shifted to palladium. Okay, here it is what is happening. So the R is breaking from palladium and joined with the CH2. Simultaneously, one of the double bonds is breaking from this carbon, CH carbon, and it is joining with the PD 2 plus, and what we get a structure like this. Okay, this step is known as, you can see that this step is known as migratory insertion. Migratory insertion. What do you mean by migratory insertion? This R group is migrating from PD, and actually this alkene, this double bond is Y bond is inserting into PD2 plus. This migration and insertion, migratory insertion. And what we get a structure like this. Here it is, our R is here, R is joined with, so here it is CH2, double bond CH2, that means here it is CH2 is here is CH2, okay, R, CH2, okay, and the one of the bonds breaks and join with, so here it is, okay, only one bond, and it is joining with PD, and here it is our L, here also L, and here it is X, of course here it is, what is that, R dash. I think this step is clear to you. The bond breaks from here and it is joining with this carbon, okay, and one of the bond break and it is joining with the PD2 plus. That means here it is RCH2 single bond, the bond is joining with the PD, L, and again +2 oxidation state, it is in +2 oxidation state, here it is R dash. Now the next step is beta hydride elimination. Hydride elimination. Beta hydride elimination. What do you mean by beta hydride elimination? Beta hydride elimination means, look at here, that means beta hydride. I am writing the same structure once again for better understanding. So here it is our R, here is H, and here is also H, and here you can see that here it is CH, here it is PD, and L, here it is X, of course, +2 oxidation state, here it is R dash. What do you mean by beta hydride elimination? This beta hydrogen, okay, that means the bond, this bond breaks from this hydrogen and the bond is shifting to here, okay, then here it will become a double bond, and simultaneously what will happen? This bond breaks from this carbon, it will be eliminated, and this bond is joining with our proton, that is what is called beta hydride elimination. This is beta hydride elimination. You can write this step here only, beta hydride elimination. Here also you can write beta hydride elimination. Then what we get? We get a structure like this. What is that? Here it is, I am writing R, okay, here it is C, here it is, that means CH, then what is that? Double bond CH, okay, double bond, what is that? Here it is CH, and a double bond R dash, okay. So look at here, how I can write, okay, here it is like this, R is here, okay, here it is double bond, and here it is okay, R, then C, double bond, then what is that? R dash. Okay, R dash, we are getting like this only, okay, R, that means here it is CH, double bond, then what is that? R dash, and what is here it is, you can see that PD is here, here it is L, here it is X, and here it will become a hydrogen. Clear? That means this bond is breaking to here, and here it will become double bond RCH, double bond R dash, and here you can see that this proton is migrating to PD, and you get again PD is in a +2 oxidation state. Okay, PD is in +2 oxidation state. This will you will get, and you can see that actually after the formation there is next is what is that? Okay, next step, that means this is not important. There is a coordination between alkene and PD2 plus. Like here you can see that there is a coordination between this newly formed alkene, substituted alkene, and what is that? PD2 plus. That means there will be a coordination between this one. Okay, immediately after this beta hydride elimination, you are getting this product, and PD2 plus this one. There is a what is that? Coordination between alkene and PD2 plus, but immediately this coordination will break, this interaction will break, and we get this interaction will break, and we get what we get? We get okay, immediately the interaction will break. And what do you mean by interaction? This again we are getting the same compound. We are double bond R dash. Okay, we get our substituted alkene. This is our substituted alkene. This is our product R, double bond R dash. This is our product. This is product. Okay, substituted alkene. And what will be become free? We can see that here you can see that PD, and here it is, what is that? Here it is L, here is also L, and here it is X, and here it is H. Okay, this part is eliminated. What is that? The product is substituted alkene. We get R, C, double bond R dash. We got this our product, and what is again? We are getting this one, PD in the +2 oxidation state. This PD compound +2 oxidation state will undergo reductive elimination. Reductive elimination. When treated with this PD2 plus, now we are treating with our base. Now the role of base is coming. Which is the base? The commonly using base is potassium carbonate. K2CO3 is used as a base. Another base we can use, or you can use triethylamine. That means NET thrice triethylamine you can use, or sodium acetate can be used. Then what will happen? They will reduce reductive elimination. What do you mean by reductive elimination? So you can see that the bond breaks from hydrogen and it will be shifted to palladium. Simultaneously, what is that? X leaving group. This is eliminated. That is minus HX. So you can see that this bond breaks from hydrogen. Proton is removed. This bond is breaking as X minus. So what will happen? HX is eliminated, minus HX, and you can see that palladium again the +2 oxidation state is changed back to 0. That means we are coming back to the first step, and the cycle is continuing like this. Okay, cycle is continuing. I think it is clear to you. So here is this step is known as reductive elimination of HX, and we come back to our PD0 compound. Again, what is that? The cycle is continuing. Oxidative addition, coordination with coordination alkene with PD2 plus, migrate reinsertion, this is beta hydride elimination. Again, there is interaction between alkene and PD2 plus. Immediately this interaction will break, and we get our final product of substituted alkene, and we again what will form PD2 plus form. That PD2 plus compound will undergo reductive elimination and will change back to PD0. Clear? Now we can take another example for a Heck reaction. Look at it here. Suppose this is our reaction. Br is here, plus it is treating with double bond OMe. Double bond OMe. This is your question. Suppose this is the in your question paper. The question is like this. I told you this is OMe. Here in the beginning itself I told R dash can be alkyl group, aryl group, or ester group. Here you can see that there is ester group. Your question is like this. It is treated with PDCl2 and PPH3 and follow potassium K2CO3. Okay, suppose this is your question. What is the product? Clear? So look at here. You can see that this is the reaction of unsaturated halide with alkene, and most important, you can see that your catalyst is palladium catalyst, PDCl2 in presence of triphenyl phosphine followed by treatment with base K2CO3. Definitely you have to predict the reaction is we have to the capacity to predict the reaction is Heck reaction. So what you will get, look at the reaction. So when you look at the reaction, you can see that what we get a structure like this. Okay, here it is double bond, and here it is what is that OM. Clear? You get this product. Okay, you get this product. Let us go to the mechanism of this product. Okay, that means you are getting a substituted alkene. One H is replaced by our aryl group. Okay, you get this product. Okay, or I can show like this. Okay, like this. Okay. Okay, you get this product. You get this product. So now let us go through the mechanism very quickly. You can see that from these two, PDCl2 and PPH3, what we will get? We get from PDCl2 and PPH3, we will get P, or is that PD, PPH3, or PD. This side also PPH3, which can be written as palladium. What is that? L. Okay. How do you get when these two are reacting? When these two are reacting, PDCl2 and PPH3, what you will get? PD, PPH3 and PD, PPH3. Okay. In this compound, palladium is in zero oxidation state. That PPH3 can be written as Al. Okay. What is the first step? Oxidative addition. Oxidative addition of our aryl halide. What is this one? Okay. Here it is. Br. What is the step name? Oxidative addition. Oxidative addition. Okay, then what will happen? The PD0 will be inserted between a carbon halogen bond. So what do we get? We get a structure like this. Okay, here it is PD, and here it will become Br. Here it is L. Here also L. And what is the next step? Insertion of alkene. That means okay, it is like double bond OMe. What is this one? Coordination of alkene with coordination of alkene with PD2 plus. Now the PD0 is changed to PD2 plus. Keep it in mind. So what do we get? We get okay. Here it is okay, and here it is. What is that? PD. Here it is. Okay, PD, and here it is Br, here it is L, here is also L, it is in +2 oxidation state. We can see that this is our double bond OMe ester group. This is here is interaction. This is what is called coordination alkene with so what do you mean by this coordination? We can see that again I am writing the same structure, or here it is like this. Here it is PD, and here it is Br, here is L, here it is L, here is our double bond. Okay, double bond OMe. This is our alkene. What will happen? This bond breaks from PD, and it will be shifted to this carbon. Okay, and okay, we have PD, and this bond breaks from PD, and it is shifting to here. Simultaneously, the bond breaks from this CH2 carbon. This will, and that will come to PD. Okay, PD2 plus. Okay, then what we get? I am starting with this one. Okay, here you can see that here it is like this. Okay, here this bond is joined with the CH2 carbon. That means there is CH2, H is here, one H, and here is another H. Okay, CH2, and now it will become a single bond, and that bond, the second bond is the pi bond is joined with the PD. So here it is PD, here it is L, and here it is Br. It is of course in the +2 oxidation state. Here it is double bond OMe. Okay, you are getting this compound. That means what is this one? Migratory insertion. Migratory insertion. Okay, migratory insertion. The next step, what is in the next step? Beta hydride elimination. Beta hydride elimination. What do you mean by beta hydride elimination? You can write the same structure once again. I am showing this structure only. What is beta hydride elimination? This bond breaks from okay, and it will be shifted to here. And what will happen? This bond breaks from here. Okay. So beta hydrogen is eliminated. That hydrogen is joining with this one, and what we get? We get a structure like this. But we get okay. Here it is like this. Okay, here and here it is. Okay, here you get a double bond, and here what do you get? Here you are getting double bond OMe. Correct? Okay, here it is CH double bond. Then what is that? This bond OMe, and plus what will form? Plus what is that? PD L, and here it is Br, and of course that proton will be attached to Br. Then what is that? Again, this is in +2 oxidation state, 2 plus. Okay, then what is that? There is a coordination between alkene and +2 PD2 plus, but that coordination will immediately, that interaction will break, and it will change into our final product. Okay, and interaction will break, and what we get? We get our product like this. Okay, here it is Okay, okay, and double bond, what is that? Double bond OMe. Okay, we get our product. Okay, substituted alkene we are getting. Substituted alkene is here. This is our product. Plus what will form? Plus what is that? Again we get here it is PD, L, here it is Br, and here it is H. And in the next step, what is in the presence of a base K2CO3, what is happening? Reductive elimination. And during reductive elimination, what is happening? This bond, this is plus 2 plus only. This bond breaks. Okay, minus H plus and minus HBr. What will be eliminated? Minus HBr, and palladium 2 plus again change back to palladium 0, and the cycle is continuing. This is the mechanism of what is that? A Heck reaction. I think it is clear to you. Now, if you take a heterocyclic halide, okay, you look at it here. What is that? Here it is S. Okay, and Br. Okay, this is 2-bromothiophenol. 2-bromothiophenol. Okay, 2-bromothiophenol is treated with, look at it here. Okay, here it is N, and here it is double bond. What is this one? This is okay. 1, 2, 3, 4. 4 vinyl pyridine. Okay, that means 2-bromothiophenol. 2-bromothiophenol is treated with 4-vinyl pyridine. Here is N is here. Okay, and in the presence of what is that? Suppose PDOAC twice, and PPH3 followed by on the base K2CO3, or NET thrice. What is the triethylamide? This can act as a base. So what is happening here? You can see that heterocyclic halide can be coupled with alkene. Heterocyclic halide can be coupled with alkene by Heck reaction. That is also very important, and we will get a coupled product. What is the coupled product we are getting? What we get? You can see that you get a compound, a coupled product like this. Okay, here it is. Okay, here double bond. Then what is that? Double bond. Here you can see that this structure you are getting. Okay, this structure you are getting. Similar. That means what is that? Heterocyclic halide compounds. Heterocyclic halides can be coupled with alkene to get coupled product. So generally we can say that Heck reaction is important for making carbon-carbon bond. Okay, and that's all about Heck reaction, and thank you.